Hi, in this video we'll talk about how methods work and how they communicate information from the driver to the actual object class that you are using. Specifically, we will understand how to declare and implement a method. And you've already done some of that. You will understand how the return statement works. Do you need one return statement? Do you need 0 return statements? Can you have multiple return statements? Understand how the transfer of information is actually being done, and understand the term local variable. And we'll use that a lot when we are talking about methods. Let's just start with a general form of a method, and you can see right here I put that it has a visibility modifier. That means public, private, who can access this method. A return type, and we'll talk about the fact that even if there is no information being passed back, you have to put something here for a regular method. The identifier should be descriptive on what is the method doing, and then what information do you have to give it. We'll call that the parameter list. You have the body of the method encased by open and closed curly braces, and we call that the implementation of the method. So an example down here, I'm just going to erase these as I discuss them. So most methods we want to be public because we want our drivers to be able to access them. Remember that this information is inside the class that you are using. And I'm just going to implement a really small method, and I'm going to name it find sum. I'm going to take the value of 2 integers and add them, and that's going to be my result. Notice I've not gone to the return type yet. So in the parameter list, when you are declaring and initializing, implementing a method, you have to have the data type of each one, and you have to have an identifier that is going to be used inside the method for each data type. So for instance, this particular method, I am accepting 2 integers, and inside this method they're going to be called num1 and num2. I also want to return an integer, and you don't give this an identifier. This right here is the return type, just like this. Okay, so there's the return type. You're just telling the driver, you're telling the class itself that you're going to do something, and it's going to be named find sum. It's a behavior available to that class. You are accepting 2 integers. You need to be fed 2 integers from the driver, and you're going to spit back to the driver an integer. Now I'll change this just for a minute and type void here. You have seen some that have a return type of void. That means you're not going to give any information back to the driver, to whomever sent the message, but you have to put void there or you'll get a syntax error. So let's change it back to how we're going to use it. And the body of this method and its implementing code might look something like this. You can have a very simple implementation. We're going to find the sum of these 2 values. All we care about is adding these together and returning that value. So one way to do it would just be to write a simple 1 statement body implementation. And you would be completely done. An alternate to that would be to make a local variable, and we'll talk about this a little bit later. And maybe you want to make another integer that is called answer. And here's what you're envisioning for answer. Answer is going to be num1 plus num2. You have something nice and solid. And then what you do is you return answer. That is equally good. In this particular case, we would call answer, ants, a local variable. Nothing else other than the inside of this method can see answer. We create a local variable, we fill it up, and then we return it. Note that if a method returns an integer, you must have a statement that returns an integer. That makes sense, right? If a method has a return type, you must have at least one return statement, but there can be more than one return statement. If there's more than one, like the next example illustrates, the first one executed ends the method. You shoot out of the method. A return statement in a void method quits the method and returns nothing. Here's an example of a method that has two return statements, right? I want to return false or true. So let's look at this. Here is the access modifier. Here's the return type. We know that it returns a Boolean. We know that it's called odd. So it's not very descriptive, but it has something to do with odd and even. And it accepts one integer parameter, which is called I, inside the method. And here's a good example of modulo division. If I mod 2 is equal to 0, right? There's two equals there, so we say equals. That's how the code reads. How I would like you to think of this is, if I is even, return false, else return true. If I is even, if you have an integer and you take modulo division by 2 of that integer, if there's no remainder, it's even, else it has a remainder of 1 and it's odd. So we take the value of this, we mod it by 2. If this is true, it's not odd, so we return false, and false is what is shot back, the Boolean value, shot back to the driver. If this return statement is reached, then the answer is given back. We are at the end of our method and completely done. If it is not even, this would be false, and we would go to the else part of this body, and we would return true. In this case, you will only reach either this return statement or this return statement, and it's perfectly fine to kick out early if you're done. Let's put the driver and the code from the actual object on the same page again. We have a student, let's call it S, and we're using the default constructor, and we have an integer called test score, and that has a value of 97. With this student S, we are going to invoke the setScore method. We remember that the setScore method takes two parameters. The first parameter represents which test is going to be changed, and then the second one represents the value that's going to be put into that test score. So let's look at some vocabulary before we talk more about that. There are specific names to these values that you put in, and we call those the actual parameters. What you are actually passing to the method is one way to remember them. In this particular case, we have a concrete value of 1, the hard-coded is what I would say, value of 1, and this one is a variable, but that variable represents the contents that we put in, 97. So what we're actually passing is 1 and 97. We can do that, once again, with the actual number or the variable representing the memory space that contains that number. These are the actual parameters that we're using. The formal parameters are the parameters in that list, like we talked about when we were just making the method above. Inside this method, inside the student class, we want two integers. One we're calling I, one we're calling score. And like this arrow says, these are called the formal parameters of the method. Eventually they will be filled with some values. And here is the values that we're getting. This one is the first parameter, so it is associated with the I. This test score variable is the second parameter, and it is associated with the variable score. Notice that I purposely named them differently. Test score is what the variable's name is called in the driver. Test score is the second parameter, and we're calling the set score method. So the set score method's parameter, the second parameter inside the method, is called score. Score and test score represent the same value, and we know already that that's 97. Within this method, it's called score, however. Here's the body of this method, the implementation of this method, and you'll see the same things, the access modifier. This does not spit back an answer. It just wants to grab test1 and give it a value of 97. It doesn't need to give back any information. Changing the value of the private data member. Set score is the identifier, and then here's the parameter list. So if I is equal to 1, which is true in this particular case, and I was the first parameter and it has a value of 1, so locally it's called I is actually 1, therefore this is what happens. Score 97 is assigned to test 1. This is a if, else structure, so we have found one that works, and so we're completely done. So we kick out of the if-else structure, and we go right here and ask, what else is going to be done in this method? Well, nothing, but this is void, so it does not have a return statement. We actually could do something like this. And return nothing, but we don't need to. Some people like to always have a return statement, but if this is void, you can't return the value of it. For instance, we couldn't return I or score. Here's another way to look at it. Here is the method being used. 1 goes to I, test score goes to score. So within the method, whatever value was passed by this is called score and used as illustrated above. If a method has multiple parameters, you must give it the right quantity and the right data types of the values. You can't switch them around. The first one passed from the driver must be the same as the first one that is accepted by the class. The actual parameters type must either be the same or less inclusive. If you have a parameter that's a double and you give it an integer, you can actually run that with no problem. Let's talk a little bit more about local variables. And I did use that phrase, but I want to expand a little bit about it. A local variable is named that way because it is used inside somewhere local, inside the method. As is illustrated in this particular piece of code, we have a method that is named getAverage, which accepts no parameters but returns an integer. Right here we make a local variable, name it average, and average is calculating the average of the test scores. What it does is it takes test 1, test 2, test 3, remember those are the private data members, and those are integers, takes those, it sums them, and divides by 3, but it divided by 3.0. So notice that this is a computation that is a double. So we have integer on the left, double on the right. So when the division is performed, the operation result is a double. And we haven't talked about the math libraries, but just like the color libraries, there is a library called math that does things that you would think, like take the cosine and sine of things. In this particular case, we're using the method round from the math library, and we made this a double so that we would round correctly. So we would round up if it was 0.5 or higher, or round down if it was not. And so we're taking that value and rounding correctly, and then casting the whole darn thing as an integer, because we want to return an integer, because we want to just represent the average of the test scores as an integer, but we want it to be rounded correctly. But getting back to the local variable, average is local to get average, is assigned, and then returned. And I'll go back to the objectives, take a look at them, and see if you understand all that we talked about.